All right, guys, today I'm going to wrap up conditional probability. Mike, part 2. Now, part 2 is kind of tricky, so I'm going to spend a lot of time doing examples and working with you. So that way when you leave, and tomorrow I'm going to give you a short quiz on what we did, and then you have the whole day tomorrow to practice on more worksheets. We're not learning anything new tomorrow, just practicing conditional probability. You have to be really strong with this stuff. Tomorrow you will have a quiz, yep, just on basic stuff, and then your true quiz on this happens later. Now, I want to give you a review question first, guys. Review. Okay. I'm not teaching anything new yet. Review. Oh, this is a review. I'll write it when we start new stuff. Okay. So yesterday, I taught you conditional probability, and be careful. I said P, A, vertical bar, B. See, this vertical bar means given that. Now, some students are so used to the idea that say, must know this is easy. In every exam question, I just look for this word given that. 50% of the time, you will not see this word given that, because it's a hidden word that you have to understand how the question's worded to realize it. I will show you that 50% today, but for now, I'm going to give you questions where you see the word given that. Okay? Try this question. A card, so example 1, just review from yesterday. Oh, sorry, P, A, B over PB. Okay? And when I do these sort of questions, I always like to start with the bottom first. It's easier in a way. Example 1, it says this, a card is drawn. You're going to draw one card. Draw one card. I don't know this class. I think last semester when I said draw one card, a student asked me, so do I draw it in red or blue ink? I don't know if this class is it. I'm like, no. Seriously. I said draw a card. Say, oh, do I use a red ink or a blue ink to do this? Draw one card. The question. Find the probability that you have an ace. You have an ace given that it's not a face card. Not a face card. Question is this. You're going to draw one card only. I want to know the probability that you have an ace given that it's not a face card. These questions are straightforward because the word given that is right in front of you. Guys, gals, I'll give you a few minutes. Let's see if we can solve this. Good luck. How do you do this? You have like 6 questions.
Hey, you never gave us any code that are not. We said is a face.
How do you figure out not a face card? How do you figure out not a face card? Think about that. Logic. It's nothing that you have to think about. 40 out of 52 is the bottom. What's on top? The key is setting up the question. 4 and 52 is correct at the top. So the key really is setting up the formula. I want P. I'm looking for an A, so let's just use A. I see the word given, not a face, so I go little F with a little bar on top. Some of you can use words, not face if you want. I like to use symbols. This is your work, you choose. So this will become P AF over PF. Okay? Simple concept like this. Now, I always like to work with the bottom first. And this is where comes a bit of logic kicks in. Okay? Michael Leon, how many cards in a deck are not face cards? Not 12, not face cards. 40. So guys, the bottom really is 40 out of 52. Because I don't want a face card in the bottom. the top takes a bit of logic. See, it says, I want an ace, and it's not a face card. Well, an ace is already not a face card. So now we just use logic. How many aces are in deck? 4. So it'll be 4 out of 52. Okay. I want you to go ahead, simplify this, and solve it. So it would be 4 over 52 times 52 over 40. And if you work that out, it gives you 4 over 40, or simply 1 over 10. Okay. And that's what we did yesterday. Very simple, straightforward. The logic part is something you got to figure out on your own. Like this sort of thing. I can't come around and show you, say, oh, by the way, that's 40 out of 52. You have to see that. Okay. So guys and gals, one more question like this and I will start your lesson for today. I'm going to flip a coin twice. Actually, I'm going to do it 4 times. Flip a coin 4 times. Probability, you have to review, that you have 4 tails given at least 1 tail is shown. I didn't write it in sentence for you, but I wrote it in this format for you. So I want to know what's the probability that all 4 or all tails given that at least one of them is a tail. Go for it. You may need a calculator, but if you want. What's on the bottom? Nope, 0.5 power 4 is not it. How do you do at least 1 tail?
Oh, 1 minus 0.1 power 4, right?
Yep. And if you're lost, make sure you just ask me. I'll come around and help you out.
Did we do the same one?
Oh, we did, but we did 3 flips last time. Nope, what's on the bottom? Start with the bottom first. The bottom is always the trickiest one to start with first.
1 minus P0?
1 minus P0. What's P0?
0.5 to power 4.
0.5 power 4 is correct. That's correct. See, the bottom is at least 1 tail. If I see the word at least 1, it's a really powerful statement. There's a special, unique way to do this. 1 minus P0. P0 means can't be tails. If it can't be tails, it has to be 4 heads. So which means you get 1 minus 1/2 times 1/2 times 1/2, but to make it simple, I go to power 4. Okay? Because which means 0 tails, no tails. It means you have to have 4 heads.
Is the 1 minus 1 over the top?
What's on? Nope, that's on bottom. Now what's on top? Probability of getting 4 tails is straight in a coin flip. Okay. Think about what goes on top.
Do you have to use fractions?
You could do it fractions if you want.
No, can we not?
You go 1/2 times 1/2 times 1/2 times 1/2, or simply 1/2 to the power of 4. Okay. And that was an actual provincial exam question. Except on provincial exams, they use 3 flips. And I've seen, and only 30% of students got this question right. Because what happened is every year, they send teachers a list of all the questions, how many people got it right. And this one, the reason students can't get this, they always have trouble with the bottom part. Because they're not strong with at least 1. Harvey, your question. Which top part? Bottom part. See, I want at least 1. If you see the word at least 1, it means 1. P0 means no tails. If you have no tails, your coin must be all heads. So to get all heads, you have 1/2 times 1/2 times 1/2 times 1/2. For a coin flip, it is. But if I have a dice question, it's different. It'd be 1 and 6. If I have time later, yep. That's how. Okay. But guys and gals, that's old stuff. Today, I want to give you the other half. And this is where your notes begin today. Guys and gals, it's Noah time. Brand new day, brand new lesson. Our traditional drawing as always. Doot, 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 doot. Gives you some time to catch up on your work. Doot, doot. This is a picture of me. Alright guys, so today I'm going to show you the other conditional. These are called, there's no name for this. First one I'm going to give you some called medical questions. Medical questions. Okay, this is first type. Medical questions. Now these are all conditional probability, except you don't see the word given that in there. I'll give you an example of question, show you how to do this. I'm going to copy down a question straight from the book. So, cancer is a huge thing that's occurring right now. And when you go for a cancer test, a test for cancer. What? A cancer test, a test for cancer is 97% accurate. Because if you read the newspaper, there are some cases of ladies or gentlemen, and they go for a test, and their doctor says, oh, by the way, you have cancer, you have 2 months left to live. So what they do is they go outside, spend all their money, and then 2 months later, doctor says, oh, by the way, I made a mistake. And she has now, so the good news is she doesn't have cancer. Bad news is she's broke. And that's a true story. So then what she did, she sued the doctor. The case is still going in court right now. You can actually read the news about the whole thing. Okay. So test for actually, there's a movie with Queen Latifah called The Last Holiday.
What?
Have you seen? It's called Queen Latifah Last Holiday. Wasn't she diagnosed with a illness or something? And then it turns to be wrong. Now here's the thing. It says, suppose 2% of the population has this disease. Yep, disease. Here's your question. What is the probability that someone tests positive have the disease or have cancer? Now there's a terminology word in here that exams like to use, and it likes to mess people up a lot. If you ever go to the doctor's office and you get tested for any disease, and doctor says you're positive for cancer, it does not mean that's a good thing. It means positive, it means bad, guys. If your doctor says you're positive for a certain disease, it means you have it. So for now, I want you to get to the idea of positive as being sick. Okay? AKA sick. I like to use the term sick and not sick. It's slightly easier. But remember, if you're positive, just remember that you're sick. Now the question is this, so you go for blood test. The test says you're positive, which means it shows you're sick. But what are the odds of you actually being sick? So this is actually a conditional probability question that's hidden. Because if you think about this, I can write this as P of cancer, of you actually having cancer. Given that you test positive, so given that, let's say, you're sick. Okay, I'm going to use the term sick instead of positive. So see, this says you test positive already, so it means given that you're testing positive, what's the chance of you having cancer? So first thing I want you to do is write down the formula right now. This is an example of something that's hidden. What's on top? P, C, and sick. Okay. Over. Nothing too bad. I'm going to use the formula P, sick. But now, the problem is, I have the formula, but I don't know how to get these numbers. So I'm going to show you how to do all medical questions. Medical questions are actually the easiest types to do. Steps to success. Steps to success. Sorry? It's going to take a while. Sub success S. Double C, double S, you always succeed. 1. Okay. You're going to draw a probability tree. Draw a probability tree. That's the first thing you're going to do. I'm going to make a little star. This is key. Star. The first branch must always be about the disease. So the first branch must always be about the disease. 2. Second thing. All your numbers must be decimals. Your numbers must be decimals. Okay, that's the next thing you got to be careful about. Fractions will not work. Fractions does not work. Does not work. I'm going to guide you through this. So we're going to start simple. A probability tree has a starting point, so we'll call that the starting point. Put a dot somewhere. And I mentioned to you that the first branch must always be about the disease. So we're going to have 2 pathways. 1 and 2. So there's going to be 2 types of people. Those with cancer, it sounds mean, and those without cancer, cancer. Okay. And I'm going to put a little bar on top to represent not cancer. So it's always about, but now, if you have cancer, and you go to the doctor to get tested, there's 2 outcomes you can have. The doctor says you're either sick, or which means you're positive, or you're not sick. Okay. If you don't have cancer, and I go get a cancer test, sometimes the test is an error, and say, Miss No, you have cancer, and say you're sick, or you're not sick. Okay. That's the first thing we're going to do. We're going to draw a tree. Our first branch must always be about the disease. Now, here's what we're going to do. We're going to fill this in. So guys and gals, I mentioned to you this from beginning, that 2% of the population have the disease. Your job is to figure out what number goes here. 97. Not 97. Not 0.2. 0.02. Because 0.02 is a probability that someone has cancer. But I don't use percent, I use decimals. That's the key. Once you have that, I want you to fill this in yourself, right here. 0.098. Okay. 0.98, not 0. Okay, so far so good. Now, here's a bit tricky. If you have cancer and you go to a doctor, what percent is accurate? 97. Put your decimal here. 0.97. Again, looks easy. Nothing too bad. I want you... Now, there's at times the test will be wrong. I want you to put that number here. Okay? Because if you go to, and the doctor says, oh, by the way, you're not sick, gives you 0.03. This is why I use the term sick and not sick. If you don't have cancer, what is the probability that the test tells you that you're sick? 0.03. Okay, this is where it gets tricky. Because if you use positive and negative, students get mixed up, say, what the heck is positive, not cancer? Okay? Sorry, what? 98? Because 2% have cancer, 98 doesn't have cancer.
What is the 0.3 at the bottom line?
0.03? See, if you don't have cancer, right, and the test is wrong, it should say you're sick. Now, if you don't have cancer, the test should say you're not sick. So what number goes here then? 0.97. That's actually the hardest part. Here comes the easy part. I look at my formula. Because they're totally different. See, what you're thinking about, this is 97 accuracy. This is people with cancer or not cancer. Okay? So they're totally different. Now, I look at my formula. My formula says P C sick over P sick. Now, there's two ways I can become sick. I'm going to ask you to circle both pathways. If you have cancer and they tell you that you're sick. Or if you don't have cancer and the test tells you you're sick. There's two pathways you can tell. There's two possible ways you can have a test that shows you're sick. So guys and gals, we're going to write down P sick equals to, look at the first pathway. The odds of you having cancer is 0.02%. The odds of you being sick with cancer is 0.97. The odds of you having both of those, so you have to multiply them together because it's an AND statement. We're going to add this because you can have the first pathway or the second pathway. Think about what you're going to add to solve it. Okay. I want you to crunch in the numbers and actually write down the answer. And if you're lost, when I come around, make sure you ask me. You can just know, I don't understand how you get sick and not sick. Yes. Where is this accuracy? Because the test is 97% accurate. No, if you don't have cancer, this should be a bar above. If you don't have cancer, the test should say you're not sick, right? It's accurate. So that's what I do. So guys, if I expand this, work this out, Chandi, what's the next thing? Plus what? 0.98 times 0.03. Punch this in your calculator, guys and gals. See, the probability of testing sick is only two pathways, this way or this way. Punch it in and you get your number or whatever that is. So let me grab my calculator. So clear up. So you got 0.02 times 0.97. Then you go 0.98 times 0.03. Add those together plus 0.0194, 0.048. 0.048. Nothing too bad. And there should be another 8 there, but who cares? Now, look at the top. So this is your bottom number right here. The top tells you you want a cancer patient who is tested sick. So there's only one pathway the top is referring to. Cancer and sick. Because that's what top refers to. The probability of someone having cancer and being sick is going to be 0.02 times 0.97 divided by 0.0488. See, I'm going to explain this one more time. It sounds confusing. See, they want top one's cancer and sick. There's only one pathway that gives you cancer and sick. I want cancer and sick. There's only one pathway, so that pathway goes on top. And punch in your calculator, and this question is worth easily 3 or 4 marks. So is it that bad? Not really. Takes a lot of work. Whoop. Why do I do bottom first? Because it's the most confusing one. Start with the hardest one first. Times 0.97 divide 0.0488. Give me 1 second. So guys and gals, it's going to be roughly 40%. So your answer is going to be roughly 0.4 or simply 40%. So the odds of someone testing positive and actually having cancer is actually 40%. So it's not, so if you test positive, it doesn't mean you have cancer right away. It's a 40% chance you will have it. Have your question. 0.04? Which one? 0.98 times 0.03? This one? Because to do the bottom part, I want sick, right? Would you agree there's two ways you can get sick? You can either have cancer, and you go sick pathway, or you don't have cancer, and you go the sick pathway. So you find each pathway by multiplying them, and because there's an OR statement, you have this pathway or this pathway, add them together, and you get the bottom number. Okay? 0.98, because 2% of population have it, so 98%. I'll give you another question. I'll explain it. Okay? So guys, I'm going to give you a question. You're going to try this. I'm going to work together again with you. So here's your question. Try this, please. 3% of the population are colorblind. Colorblind. I'm just making it up. I just made it up. It could be more. Who knows? A test of the population for color blindness. There's actually a neat test for color blindness. What they do is give you a picture with a number 1 in it, and they say, what do you see? And some people say, oh, I just see a circle. And if you're not colorblind, you see the number 1. Yep. A test for colorblind is 88% accurate. So this test is 88% accurate. You can't if you're color. You can't even wear glasses for cop. Yep. Here's your question. Find the probability of someone I can lie. Who knows? Oh, that's a nice red shirt you're wearing. Find the probability of someone having eye disease. Sorry, having this eye disease. It's transferable. You can transfer it to your kids. Having this eye disease. If their test is positive. Actually, I'm going to use the negative. If their test indicates negative. Indicates negative. Okay. So I go for the test, and all of a sudden the doctor says, hey, good news. Your test shows you're negative. Now, based on that fact, what's the probability that I have the disease given that my test is negative? Good luck. So this is an actual what people have to do. Question right here. Sorry? Okay, so here. There's different types of colorblind. There's people who get green and red mixed up. There's people who can't just see it black and white. There's different types of colorblind.
Dogs can see only black and white.
Guys, get cracking this one. So, here's an example of a question. It says, find the probability of someone having the eye disease if their test indicates negative. So this is an example of something. Like I said, you don't see the word given that, but you should be able to follow that example what I did. And if you need a hint, guys, you should have 2 branches right off the bat. Good luck. What goes into the branches, you tell me. Fill it in, and then write down your formula right now. Oh, it should be I and colorblind and uncolorblind. It's not second. You get 2 with that. You use the term disease and no disease. So that's it. And the key So I'm just gonna label the first branch and make sure you see if you get it correct. I'm gonna use this term colorblind and not colorblind. Okay, that's what I'm gonna do. The first branch must always be about the disease. Now, 3% of the population are colorblind. Jimmy, what number goes here?
I think 3.
Not 3.
03.
0.03. That's all I'm going to do. I'm going to start off first. Very nice, simple. Ahmed, what number goes on the bottom, sir? 0.97 is correct. Now, if you're colorblind and you go to the doctor says you're either sick. I like to use the term sick or not sick. Some people like to use negative, positive. I find it a bit more confusing. Okay. Sick or not sick?
Can you say disease, not disease?
Say whatever you like. But I use, like I said, you can use whatever is familiar for you. As long as you get confused. Okay. Now, here's where you got to be careful. 88% accurate. You got to be careful where the 88 goes. 0.88 goes on top is correct. Gives you now, Javier, what number goes on the bottom right here? 0.12 is correct. Okay. Now, here's where it gets a bit tricky. What number goes here? 0.12 is correct. Some students put 0.88 here. That's where they make the error. Now, 0.88. Well, if you could, or you can use logic. No, it depends where I put sick and not sick. Okay?
If you put in the order, always be opposite.
Well, you can, like I said, try to use logic to get it. So I look at my formula. I want to know someone actually having disease, let's say who's colorblind, given that they have a not sick. Okay? Because not sick. Because it means negative means not sick. So guys, find all the pathways where you're not sick and highlight it. Highlight the pathways where you're not sick. You know what the answer is? No. I know what the work is. What? I know I'm looking at the work. Work is more important.
Not sick or sick?
Negative. Negative means what? No. Oh, good. Well, what do you have to tell me? How do you know which one to use? Because it says what? First one? Because look at my formula. My formula is P, C, and not sick. So guys, first key. Expand this out. P, C. This is why you need to know the formula. P, C, and not sick over P, not sick. Okay. I just use the formula. There's two pathways where you're not sick. You're colorblind and you're not sick. Or you're not colorblind and you're not sick. Okay. And all I'm going to do is plug in the formula. That's it. Keep it simple. So you go 0.03. This is the bottom. I'm going to start with the bottom first. Times 0.12 plus 0.97 times 0.88. Why? Because would you agree I can have the top pathway or the bottom pathway? It's an or statement. Or, yep. 0.3?
0.3 and 0.88 and 0.97.
No. So this is probability. Why do you add it? Here's the reason why. See, would you agree there's two pathways that can give you not sick? This pathway, which is 0.03 times 0.12. Or, what? You can have the bottom pathway. What? Guys, now, we do the final thing. P. A lot of you ask what goes on top. Oh, I'm not gonna explain, guys.
So why do you have it?
Why'd you have PC and not sick. Okay. Figure out what pathway you want. I want colorblind and not sick. Which is, give me one, 0.03 times 0.12 all over whatever this is. 0.85? 72. So this is, I'm going to hear 0.8572. Punches in your calculator, guys. 0.03 times 0.12. Because right here, I want C and not sick. C? Because I don't want a sick person, no.
You want a not sick, right?
So C, colorblind and not sick. Well, bottom one, we don't need it. Because look at the formula. C and not sick. Nope. Because look at it. Look what you want on top. C. C means colorblind, right?
Yeah.
Colorblind and...
Sick.
No. Not sick. Colorblind and not sick, which is 0.03 and 0.12. And I think you punch it in, you have like say 0.4%. 0.4% or 0.004, I think. Something like that. Guys, gals, that's your medical question. One last question, and that's it for today. 0.004? That's 0.4%. Oh, please. That's why you're in Math 12. I know. Last thing. The last type of question you got to be careful about, something called defective / I call this defective questions. Here is how this one works. Very similar to the disease question. All you have to do is set it up. I'm going to give you the question, and I'll just set it up, and we'll see how you can figure this out. So there's two companies. Company A produces 70% of school, something to do with school tiles. Yeah, I'm making up. Company 80% of school tiles. Now, company B produces 30%. Very simple concept. Okay. Company A has a defective rate of 4%. So every tile that company A produces, 4% of them will be broken. Okay. Company B has a defective rate of, let's say, 7%. Okay. So here's your stats. Your question is this. What's the probability that a broken tile, so I'm going to pick up any random broken tile from a huge pile. Broken tile came from company A. Okay, so let's explain this again. So in other words, I have this massive pile of tiles. I reach in one of them and I notice it's broken. Your question is this: what's the probability that this tile came from company A? This is another conditional probability question where you don't see the word given that. The key you have to see is how you set up this question. Guys, gals, set up the formula P, figure out what goes where. It's a given that statement, but it's hidden. Let's see how we can set up the formula first. So A, vertical bar. A is correct. Some of you may use the word company A. I'm going to use the letter A. A, and I want a broken tile, so this tile we know is going to be broken. Or I turn and call it defective. Call it whatever you like, broken, defective. That's why I call this a defective question. Okay. Right off the bat, write down the formula. Okay. I set it up, now you write down the formula. Yep. It matters because it says, look, says, what's the probability that broken tile came from company A? Means you have a broken tile, given that it's broken. That's where you got to be careful about. Okay. So therefore, what's the formula going to be? P over P defective. A and defective. This is nothing. What you're going to do? You're going to create a probability tree again. All this is based on probability tree. I'll set it up for you. There's two companies, A or B, just like you have diseases, two types of people. You get disease or not. A, company A will produce two types of tiles. One that's defective and one that's not. Guys, gals, company B also has two types of tiles. This is how you set this up. Only thing I'm missing now are numbers. Your job is fill in the numbers. Pretend this is like a medical question. And once you figure out, start with the bottom number first. Figure out what goes in the bottom. So every question is basically the same. It's just a matter of, can you set it up? On exam, there's a hockey question and not hockey question. Something to okay, now last semester's exam. I think Carlos is your class. There's a hockey question. East hockey and West hockey or something.
Is this right?
Okay, now what's the find defective? So how many pathways gives you defective?
No.
Circle all the defective pathways. Yep.
Wait, what's this?
Defect. Look at the defective rates. 7% or not?
Oh. Yeah, correct.
So what I'm going to do is fill in the formula. Plug it in now. A has a defective rate of, so this is 0.7 and 0.3. Always equal to 100. Yep. Nope, 0.7. Now A has a defective rate of 4%. 0.04. 0.96. 0.07. 0.93. If you're lost, make sure you ask me. I always start with the bottom first. Defective. There's two ways you can get defective. Highlight both pathways and fill in the numbers for me, please. Okay? Just like the medical question. How many ways can you become sick? Okay. And look what goes on top. Use logic to get the top number. And that's all there is to it. Every question works the same concept. Are you all? It is. Now what are you going to do with those numbers, Carter? Okay, now what goes on top? What goes on top? That's what I want to know next.
Is it not defective or defective?
Defective. Top part's wrong. Bottom part is. It is. See, top part says this. I want A and defective. Look, there's only one way I can have A and defective. Okay, that's what it means and. So A, top is 0.7 times 0.04 is correct. Now the bottom number, there's two ways you can have defective. There's this way, and there's this way. Guys, gals, fill this in on the bottom, just like medical questions. So really, all these questions are the same, except worded differently. Plus 0.3 times 0.07.
How do we got the top?
Okay, look at top. What does this mean?
A
A and
defective.
okay. You want a pathway where it says A and defective.
Or,
Punch it in your calculator and you get your answer. And that wraps up conditional probability part 2. Oh, it is. If I didn't explain to you, you'd say, must know what the heck is this?
That was really weird, like counter, like setting stuff.
So guys, your work. I want you to practice. Tomorrow there's a quiz on this sort of thing. You have to be ready by tomorrow. Page. We're going to spend about one more day doing conditional probability. Conditional probability tomorrow. This stuff and yesterday's stuff. What I taught you. Your test is next Friday. Oh, you're not done yet. This is only halfway through the chapter. This stuff and the next thing is almost slightly easier. Page 121. No. There's some questions you can't do yet until explained. Number. I gave you some numbers last time already. I'm going to add it more to this. So number 12. 13. Oh, no. 17. 18. 26. 28. There's one question you must do, and this is going to be number 16. This is a crucial question. Because 16 I saved the best for last. Guys and gals, you have a quiz on this stuff tomorrow. Tomorrow I have a worksheet on conditional probability for you to do. And, oh please, there's only 5 questions, princess. Let's get it going.
Can we start up corrections right now?
Oh, no. No corrections right now. Oh, please, guys, get crack-a-lacking. No. Quiz.